In this section, we'll look at simplifying radicals. So let's start with the warm-up. We have x times x times x times y to the fourth. And if you remember the exponent rules, we have three x's multiplied by each other, so that's x to the third. And then if you think about how many y's you're multiplying together, 4y's times another y, you'd have 5y's. So this is x to the third times y to the fifth. We have two goals today. Can you simplify, well, a few goals. Simplifying radicals by pulling out perfect squares, perfect cubes, and we're going to look at simplifying radicals, and I should change this. We're going to look at simplifying radicals with the coefficient and also with the denominator. So several types of problems we're going to see in today's lesson. So first, let's identify parts of a square root or radical. So square roots are a type of radical. I should be saying radical. And here are the different parts of a radical. The radical symbol is this sign that we often associate with the square root. So this is our radical symbol. Sometimes you have a number right here. This is called the index. And usually if you don't see an index written, so if there's no index, it's a square root. The index is 2. You have your number under the radical sign, so this is called your radicand. And then sometimes you have a number on the outside, and this is called your coefficient. And all of these parts make up a radical. So we're going to be taking a look at that today. Alright, so let's start with square numbers, numbers that you've seen quite frequently in math. So 1, 4, 9, 16, 25, and 36 are all called square numbers. Explain why they are called square numbers. Well, if you look at the area of a square, the area of a 1 by 1 square is 1. The area of a 2 by 2 square is 4. The area of a 3 by 3 square is 9. A 4 by 4 square is 16. Going to make my 9 look better. And the area of a 5 by 5 is 25. So they're called square numbers because it's coming from multiplying a number by itself or by finding the area of a square. So the area of a square comes from multiplying a number by itself. Multiplying a number by itself. Alright, so then in class we talk about all the square numbers from 1 to 144. So 1 times 1 is 1, that's a square number. 2 times 2 is 4, that's a square number. 9, 16, 25, 36, 49, 64, that's 8 times 8, so 9 times 9 is 81, 100, 121, and 144. So you should be able to recognize these numbers pretty easily as we simplify our square roots. So let's get into it. Simplify the following square roots. What number times what number is 1? That's 1. The square root of 4 is 2, because 2 times 2 is 4. The square root of 9 squared is 9, because that would be the square root of 81, which is 9. The square root of x squared is x. So we'll do a little mini investigation. How can you simplify a non-perfect square number, because all the ones above are perfect square numbers? In other words, how can you give an exact answer? So if we take a look at our triangle here, this little line right here means our sides are the same. And if you remember from geometry, if you have a right triangle, you can figure out the hypotenuse by using Pythagorean theorem, which is 3 squared plus 3 squared equals c squared. 9 plus 9 would give us 81. 9 plus 9 would give us c squared, not 81. 9 plus 9 would be 18, not 81. And that would be c squared. And then to get rid of the squared, use square root. And so that side is the square root of 18. And usually we get the decimal, but our goal today is how can we rewrite square root of 18 so it's not a decimal, but still simplified. So here it is. What if a number is in a perfect square? For example, simplify the square root of 50. So here are the steps. Think of your list of square numbers. What's the biggest square number you can divide 50 by? It's 25. 25 and 2 are factors of 50. They multiply to 50. So you rewrite the radical with the square number first, and then you simplify. The square root of 25 times the square root of 2 is 5 square root of 2. So let's try an example here. What's the biggest square number you can divide 40 by? And that is 4. So you test all the numbers under 40, and 4 is the biggest one. We can rewrite that as square root of 4 times the square root of 10. We can pull it apart, square root of 4, square root of 10. And then to simplify, you pull out that square number. So we say the square root of 40 is the same as 2 square root of 10. Let's try another one, square root of 48. Again, we want the biggest square number we can divide 48 by. So you can divide it by all the numbers underneath 48. And that would be 16. So we can rewrite this as the square root of 16 times the square root of 3. Put your square number first and rewrite that. That is 4 square root of 3. And that is an exact answer. So let's try another triangle problem. Can you get the missing side again? Pythagorean theorem. We got 4 squared plus 8 squared equals c squared. That is 16 plus 64 equals c squared. If we simplify that, that's 80 equals c squared. To get rid of the squared, use square root. And what is the biggest square number you can divide 80 by? Well, that's 16. 16 times 5. And then to simplify, the square root of 16 is 4. So 4 square root of 5 is the same as the square root of 80. All right, so we can simplify square numbers by pulling out the biggest square number, and we can do the same thing with perfect cubes. So let's list all the perfect cubes from 1 to 1,000. Whoops, I want to erase this. Okay, so here we have 1 cubed, here we have 2 cubed, 3 cubed. I'm going to put the numbers I'm cubing on the bottom. It helps me keep track of them. Okay, so 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, I'm running out of room here, and 10 cubed is 1,000. All right, so in our calculator we can type that in, cubed root of 8, and we would get 2. The cubed root of 729 is 9. The cubed root of 512 is 8. So those are perfect cubes. If you type them in, you get a whole number. But what if it's not a perfect cube? So we're going to do the same thing. Pull out the biggest cube. So if we take a look at this one, what's the biggest cube number I can divide 16 by? It's 8. So you write this as 8 times 2. Then pull out your perfect cube. So I'm just going to circle what I'm going to pull out. I know that the cubed root of 8 is 2. So we have 2 times the cubed root of 2. And there's your answer. Let's try the next one. What's the biggest cube number you can divide 3,000 by? And that's 1,000. So I can split it apart like this. We got 1,000 times 3. And again, I'm going to circle what I'm going to pull out. The cubed root of 1,000 is 10. So we're left with 10 cubed root of 3. And the last one, second to last one, 250. What's the biggest cube number I can pull out of 250? Well, that would be 125. I'll just leave it here. So this is, cubed root of 125 times 2. And so if I pull out that perfect cube here, that would be 5 cubed root of 2. And the last one, 32. What's the biggest cube number I can divide 32 by? That would be 8. So I can rewrite this as 8 times 4. And again, I'm going to pull out that 8. The cubed root of 8 is 2. So 2 cubed root of 4. Okay, so it's very similar to pulling out perfect squares, except we're pulling out perfect cubes. All right, part 3. What if there's a coefficient in front? How can you simplify? So for the first one, we have 5, and I'm going to simplify the square root of 18 as the square root of 9 times the square root of 2. All right, and I know that the square root of 9 is 3. So this is 5 times 3 times the square root of 2, and that is 15 square root of 2. Let's try the next one. Again, I'll leave that 10 alone for now. What's the biggest square number you can divide 56 by? That would be, I think 4 is the biggest. So 4 times 14. So I can rewrite that as 10 times 2, because the square root of 4 is 2, square root of 14. And so my answer would be 20, square root of 14. So if there's that number in front, you can multiply it to whatever you pull out. The next one, we have 2 times, well, the square root of the cubed root of 8 is 2. So this is 2 times 2, and that's 4. And the last one, we have 6 times the cubed root of 128. Okay, so this one, the biggest cube number I can divide 128 by is 64. So I'm going to pull that out. This is 4 times 4 times 4, so that's 6 times 4 times the square root of 2. And if we multiply those together, we get 24 square root of 2. Okay, so we had to pull out that perfect cube first, and then we simplify. Okay, what if there's a denominator? Okay, so let's take a look at this right here. So first is the square root of 18. We just did that. That was the square root of 9 square root of 2 over 3. The square root of 9 is 3, so we have 3 square root of 2 over 3. And these cancel, so our answer is square root of 2. Okay, let's try the next one, square root of 56. Again, we just simplified that. That's the square root of 4 times the square root of 14 over 4. So if we look at that, that's 2 square root of 14 over 4. And then we can simplify. 2 divided by 4 is the same as 1/2. And so there's our final answer, square root of 14 over 2. So again, I can divide the top and the bottom by 2 and get square root of 14 over 2. All right, the next one, cubed root. Oh, okay, so the cubed root of 8 is 2, so this is 2 over 8. That reduces to 1/4. And the last one, again, we just simplified this. This was the cubed root of 64, we did up here, times 2 over 12. And if we pull out this perfect cube, that's 4 square root of 2 over 12. And I'm going to run out of room here. So think, how can we reduce this fraction? We can divide 4 divided by 4 is 1, so we have square root of 2. And 12 divided by 4 is 3. So this would be the square root of 2 over 3. All right, so we looked at several types of problems here. And in your assignment, you'll be simplifying these radicals.